Hello. Welcome back to day 23 of reading NestJS almost every day from start to finish until we finish reading the NestJS documentation. Again, this is our day 23 and we are at the techniques part, Mongo model, we are on to connection. And yeah, for those of you that are new here, make sure to like and subscribe and read along with me. Connection. At times, you may need to access the native Mongoose connection object. For example, you may want to make native API calls on the connection object. You can inject the Mongoose connection by using the inject connection decorator as follows. Injectable. Export class get service constructor inject connection private connection. Sessions. To start the session with Mongoose, it's recommended to inject the database connection using inject connection rather than calling Mongoose start session directly. This approach allows better integration with the NestJS dependency injection system, ensuring proper connection management. Here's an example of how to start a session. Injectable export class get service constructor inject connection private read only connection. Async start transaction const session equals to await this the connection start session.start transaction. In this example, inject connection is used to inject Mongoose connection into the service. Once the connection is injected, you can use connection start session to begin a new session. This session can be used to manage database transactions, ensuring atomic operations across multiple queries. After starting the session, remember to commit or abort the transaction based on your logic. Multiple databases. Some projects require multiple database connections. This can also be achieved with this module. To work with multiple connections, first create the connections. In this case, connection naming becomes mandatory. After module ts, module imports Mongoose module for root MongoDB, localhost test, connection name cats, Mongoose module for root, this time MongoDB localhost users, connection name users. Notice, please note that you shouldn't have multiple connections without a name or with the same name, otherwise they will get overridden. With this setup, you have to tell the Mongoose module for feature function which connection should be used. Module imports Mongoose module for feature, name, cat name, schema, cats. You can also inject the connection for a given connection. Injectable export class cat service, constructor inject connection cats, private connection. To inject given connection to a custom provider, for example, factory provider, use the get connection token. Use the get connection token function, passing the name of the connection as an argument. Provide get service, use factory gets connection, return new get service, gets connection, inject get connection token cats. If you're just looking to inject the model from a named database, you can use the connection name as a second parameter to the inject model decorator. Get service ts, export class get service, constructor inject model cats. Cat name cats, private cat model cat. Hooks, middleware. Middleware, also called pre and post hooks, are functions which are passed control during execution of asynchronous functions. Middleware is specified on the schema level and is useful for writing plugins. Source. Calling pre or post after compiling a model does not work in Mongoose. To register a hook before model registration, use the for feature async method of the Mongoose module along with the factory provider, i.e. use factory. With this technique, you can access a schema object, then use the pre or post method to register a hook on that schema. See example below. Mongoose module. So module imports Mongoose module for feature async. Name, cat name, use factory, and we provide a function. Const schema equals to cat schema.pre, save function, console log, hello from pre-save, return schema. Like other factory providers, our factory function can be async and can inject dependencies through inject. So we have imports Mongoose module for feature async, name cat name, imports config module, use factory, config service, and we can use the config service inside here. And we have to inject config service here. Plugins. To register a plugin for a given schema, use the for feature async method. Imports Mongoose module for feature async, name cat name, use factory, const schema, cat schema, schema plugin, require Mongo's auto-populate, return schema. To register a plugin for all schemas at once, call the plugin method of the connection object. You should access the connection before models are created. To do this, use the connection factory. Module imports Mongo's module.forRoot, MongoDB localhost test, connection factory, connection plugin, require Mongo's auto-populate, return connection. Discriminators. Discriminators are a schema inheritance mechanism. They enable you to have multiple models with overlapping schemas on top of the same underlying MongoDB collection. Suppose you wanted to track different types of events in a single collection. Every event will have a timestamp. So we have a schema, discriminator key, kind, export class event, and we have kind and time, and inside the prop for kind, which is of the type string, required true, enum, clicked link event.name, sign up event.name. Prop type date, required true, time date. Hint: the way Mongoose tells the difference between the different discriminator models is by the discriminator key, which is something t by default. Mongoose adds a string path code something underscore t, which is underscore t by default. Mongoose adds a string path code underscore t to your schemas that is used to track which discriminator this document is an instance of. You may also use the discriminator key option to define the path for discrimination. Sign-up event and click link event instances will be stored in the same collection as generic events. Now let's define the click link event class as follows. So this is a click link event schema.ts schema, export class click link event, kind string, time date, prop type string, required true, URL string. And sign up event class, so very similar, sign up event, kind string, time date, and user string, and it's of the type string, and required is true. With this in place, use the discriminator option to register a discriminator for a given schema. It works on both Mongoose module.forFeature and Mongoose module.forFeature async. So we have imports Mongoose module.forFeature, name, schema, event schema, discriminators, and this is an array of objects, and we have an object name, clicked link event.name, schema, clicked link event schema, and we have the same equivalent object for sign up event. Testing. When unit testing an application, we usually want to avoid any database connection, making our test suites simpler to set up and faster to execute. But our classes might depend on models that are pulled from the connection instance. How do we resolve these classes? The solution is to create mock models. To make this easier, the NestJS Mongoose package exposes a getModelToken function that returns a prepared injection token based on a token name. Using this token, you can easily provide a mock implementation using any of the standard custom provider techniques, including use class, use value, and use factory. For example, providers cat service, provide getModelToken cat.name, use value cat model. In this example, a hard-coded cat model object instance will be provided whenever any consumer injects a model cat using an inject model decorator. Async configuration. When you need to pass module options asynchronously instead of statically, use the forRoot async method. As with most dynamic modules, Nest provides several techniques to deal with async configuration. One technique is to use a factory function. Mongoose module.forRoot async, use factory, which is a function of the output URI MongoDB localhost Nest. Like other factory providers, our factory function can be async and can inject dependencies through inject. Mongoose module.forRoot async imports config module, use factory async config service to config, which is of the type config service, which has an output of URI config service .getString MongoDB URI, and don't forget to inject config service, as always. Alternatively, you can configure the Mongoose module using a class instead of a factory, as shown below. Mongoose module.forroot async. Use class mongoose config service. The construction above instantiates Mongoose config service inside the Mongoose module, using it to create the required options object. Note that in this example, the Mongoose config service has to implement the Mongoose options factory interface, as shown below. The Mongoose module will call the create Mongoose options method on the instantiated object of the supplied class. Export class Mongoose module Mongoose config service implements Mongoose options factory. Create Mongoose options Mongoose module options. Return URI MongoDB localhost nest. If you want to reuse an existing options provider instead of creating a private copy inside the Mongoose module, use the use existing syntax. Mongoose module.forroot async imports config module use existing config service. Connection events. You can listen to Mongoose connection events by using the onConnections create configuration option. This allows you to implement custom logic whenever a connection is established. For instance, you can register event listeners for the connected, open, disconnected, reconnected, and disconnecting events as demonstrated below. So we have a Mongoose module.forroot MongoDB localhost test, and we have an object as the second input. Where in the object we have onConnection create connection, which is of the type connection, and it's the result. The output is connection.on connected, console log connected, and we have it the same for connected, open, disconnected, reconnected, disconnecting, and it returns connection. In this code snippet, we're establishing a connection to a MongoDB database at MongoDB localhost test. The onConnection create option enables you to set up specific event listeners for monitoring the connection status. Connected, triggered when the connection is successfully established. Open, fires when the connection is fully opened and ready for operations. Disconnected, called when the connection is lost. Reconnected, invoked when the connection is reestablished after being disconnected. Disconnecting occurs when the connection is in the process of closing. You can also incorporate the onConnection create property into async configurations created with Mongoose module.forroot async. So we have Mongoose module.forroot async use factory URI MongoDB localhost test onConnection create connection and register event listeners here and return connection. This provides a flexible way to manage connection events, enabling you to handle changes in connection status effectively. Subdocuments. To nest subdocuments within a parent document, you can define your schemas as follows. Schema, export class name, first name, so we have prop, first name string, prop, last name string. And then reference the subdocument in the parent schema. So you have schema, export class person, add prop name schema, name, export constant person schema, and we have the same as always, schema factory create for class person. Export type person document override, name, types, subdocument, types, object ID, and name. Export type person document, hydrated document, person document override. If you want to include multiple subdocuments, you can use an array of subdocuments. It's important to override the type of the property accordingly. You have a schema, export class person, prop name schema, name, which is an array of name, export constant, person schema, schema factory that create for class person, export type, person document override, which is of the object equals to an object name dot name, types document array name, export type, person document, hydrated document, person document override. Virtuals. In Mongoose, a virtual is a property that exists on a document but is not persisted to MongoDB. It is not stored in the database, but it is computed dynamically whenever it's accessed. Virtuals are typically used for derived or computed values, like combining fields. For example, creating a full name property by concatenating first name and last name, or for creating properties that rely on existing data in the document. We have class person, prop first name string, prop last name string, virtual get function, this person, return this first name, this last name, full name string. Hint, the virtual decorator is imported from the NestJS Mongoose package. In this example, the full name virtual is derived from the first name and last name. Even though it behaves like a normal property when accessed, it's never saved to the MongoDB document. A working example is available here. So that's the end of Mongo section, and tomorrow we'll move on to validation, which is also another important aspect of web development and backend development. Hope you guys enjoyed it here, and make sure to like and subscribe. Bye everyone. See you.